Hopefully you put some thought into how you could find the sum of the interior angles in that regular pentagon. And again, 2 ways was really the goal that I was wanting you to accomplish. Here's a couple ways that I've seen in the past that people have attacked this problem with. One of them was use that idea of what you did yesterday or did Monday by creating these isosceles triangles inside the figure. The reason that might be helpful is, first of all, I can figure out the measure of the angle here in the middle. And we know that that already is going to be 72 because we take 360 divided by 5 in this case. And then since it's an isosceles triangle, we can take that 72 away from 180. We can divide it by 2, which tells me this angle is 54, and so is this angle. Now, keep in mind, I want the entire angle here. So that's 54 on this side, but if it's really the same triangle all the way around, all of these should be 54. Or in other words, I have 10 of those 54-degree angles. And so that's one way I could get my 540 degrees. Another method that I ordinarily see is this. You look at your figure and break that figure up into, in this case, 3 triangles, because I know every triangle has 180 degrees. And I've got 3 of them in this picture, so if I take 180 times 3, I get my 540 degrees. So those are usually the 2 most common ways that I've seen people come up with this answer. Doesn't mean it's the only 2 ways we can do it, but those are 2 of the more common ones. Well, here's what we want to try to figure out. We want to try to figure out eventually, all right, we know what's going on now with the 5-sided figure. We know it has 540 degrees. But what about these other figures? It's a way that, first of all, we could look at these other figures and maybe find the total. But eventually, is there a way that we can find a pattern that will help us maybe get that sum of the interior angles pretty quickly? So let's look at this 4-sided figure, this square, and let's think about what that's going to add up to. Well, we already know with the square we got 4 90-degree angles. So if I add all those together, we know we're going to have 360 degrees. And that's actually something we've mentioned from time to time already. Let's see if we can find a pattern that's happening. Well, we had 180 and then we had 360 when we added a side. Then we had 360 and we added 180 when we added a side. So it looks like my pattern is I'm going to add 180 as I go along. So that would mean my 6-sided figure should have had 720 degrees. My 7-sided figure should have 900 degrees. If I keep adding 180, I can fill in the rest of my table. Now you'll have to notice we went from 10 sides to 12 there at the end. So you had added 180 twice. So those should have been the values that you got inside your table. Well, that's great, because there is that pattern of adding 180. But if I said, okay, I want to know, well, how many degrees are there in a figure that has 50 sides? Well, I don't want to sit around and keep adding 180 and adding 180 and adding 180. So I want to have a faster way. I want to be able to have an equation where if I told you the number of sides, you could plug in that number of sides to my equation, and you would eventually figure out how many degrees it has. Well, let's go back to that second method that I showed earlier, where I took a figure and I divided it into triangles. For instance, if I took my four-sided figure, I could really create two triangles. So I have two triangles, they're both 180 degrees, that gives me 360. If I looked at my six-sided figure, I can break that into 1, 2, 3, 4 triangles. Each of those are 180 degrees. If I moved on to an octagon, an eight-sided figure, let's see how many triangles I can make out of that. I've got 1, 2, 3, 4, 5, 6 of those triangles. And all of those are equal to 180. So if I take 6 times 180, I get that 1080 at my table pattern. All right, well, there is kind of a pattern going on here if we look at all these. On each of those examples I just did, every single time I had to multiply by 180. So the 180 seems like that's a constant. The question becomes, well, where did the 2 come from? Where did the 4 come from? Where did the 6 come from? Let's think back to how many sides we had. For this first figure, I had 4 sides, and I multiplied by 2. This next figure, I had 6 sides, and multiplied by 4. This last figure, I had 8 sides, I multiplied by 6. My goal here is to try to figure out, well, what if I have n sides? What am I going to do? Well, I know I'm going to end up with some number that eventually I multiply by 180. And if I look at my pattern, well, to get from 4 sides down to this 2, I subtracted 2. To get from 6 down to 4, I subtracted 2. To get from 8 to 6, I subtracted 2. So if I have n sides, I'm going to have to take n minus 2, and then I'm going to multiply that by 180. So my formula that I'm going to use for finding the inside or interior angle sum is I'm going to take n minus 2, or the number of sides minus 2, times 180. Let's see how that might help us on a certain problem. So if I had this problem here where I'm looking for eventually what m is, I have to ask myself, first of all, okay, I've got all these angles. What should all these angles add up to? Well, that's where this formula, this n minus 2 times 180 is going to come in. So if I look at my figure, I've got 1, 2, 3, 4, 5, 6, 7 sides. And notice, whenever I have 7 sides, that also means I have 7 angles. So I'm going to ask myself, well, what's the goal here? How many degrees should I end up with if I have a 7-sided figure? So I'm going to plug 7 in for n, and I'm going to figure out what my goal is. So if I take 7 minus 2, that's 5. 5 times 180 is 900. So that tells me when I add up all these angles, I should end up with 900 degrees. So let's start adding up these angles. Well, I've got n plus 13. I've got 138, 106. I've got m minus 9. We got m. We got 133, and I got 120. And all those should end up equaling 34. Now, let's redo that there. Move it around. stuff. Let's do this. Really move over. There we go. All right, so I'm going to take all of this and I'm going to set it equal to 900. Now, if you were doing this problem, you wouldn't have to list out all those parts. If you want to go ahead and just do your addition as you go, that would have been fine. But what do we have? We have m plus another m plus a third m. So I've got 3m. I want to add the numbers together. 13 plus 138 plus 106 plus 501. And so now I can solve this by subtracting the 501. And then dividing by 3. So when I divide by 3, I find out that m has a value of 133. So coming up with a goal, what should all those add up to? And then from there, setting up my equation. All right, here's the next one. We have this figure that has 1, 2, 3, 4, 5, 6 sides. Every angle is marked with X. In other words, this has to be a regular polygon. All the sides and all the angles would have to be the same length. So again, I got to come up with a goal. So my goal, since I have 6 sides, would be 6 minus 2 times 180. Or 4 times 180 would be 720. I've got 6 of those x's that now should equal 720. Or each of those angles should have been 120 degrees. So we came up with the goal, set up the equation, got our answer. All right, why don't you do this? Why don't you pause the video and see if you can figure out this next figure. Notice in this next figure, we're going to try to figure out, well, what's the value or the angle measure for K. All right, so go ahead and pause the video, try this one, and then you can start it back up to see how you're going to attack this. All right, well, you can attack this a couple different ways. What I would probably do is start with that isosceles triangle up top, and I'm going to find those 2 missing angles. So I'm going to take 64 away from 180. I'm going to divide by 2, and I find out that this angle is 58, and this angle is 58. Then, if this angle is 58, I should be able to find the angle next to it, because I know those add up to 180. So I find out this angle is 122 degrees. Well, essentially, I'm done with that top triangle, and I'm going to now focus on this figure. So, in that figure, I've got 1, 2, 3, 4, 5 sides. So my goal is 5 minus 2 times 180. Or, we already decided that was going to be 540 degrees. All right, so we're going to add things up. So I've got 88 plus 122 plus 90 plus 96 plus that K value, and all that should equal 540. And again, you wouldn't have to, on this problem here, you wouldn't have to write out the equation necessarily. You could just maybe start subtracting from the 540. So I'm going to subtract all those things out and see what I'm left with. K, it turns out, is 144 degrees. All right, one last example. Again, let's pause the video, see if you can work this one out, and then you can check your answer after that. All right, let's see how we could possibly attack this problem here. It was a little different because they threw in some parallel lines. The tricky part on this one was I don't really know what this measure is. I don't really know what this measure is. However, I do know with these parallel lines and this transversal, that those two question marks have to add up to 180 degrees. So it really doesn't matter exactly what they are. Maybe one of them's 30 and one of them's 150. Maybe one's 20 and one's 160. It doesn't really matter. But I do know that those two together have to be 180 degrees. So I've got 1, 2, 3, 4, 5-sided figure again. So I know that equals 540. I know two of those angles equal 180 when I put them together. Plus I've got this angle. So far I've taken care of those two. Now I've got the 135. Plus then I have a 2y and a 3y. And all those should equal that 540 because, again, it was a 5-sided figure. And now we can solve this equation. So when we solve this equation, we get 5y is equal to 225. And so when I divide by 5, you should have found out that y was equal to 45. So for right now, the big idea that you have to be comfortable with is in order to find the sum of the interior angles, all the angles on the inside, we're going to do n minus 2 times 180. So we're going to use that formula that we came up with here. So somewhere you need to make sure that you write that formula down, and we'll use it quite a bit, so you'll remember it. But for right now, I'd write that down somewhere so you remember that this is how we're going to find the sum of the interior angles.